Let's look at this question. A survey was conducted in one of the schools in Limpopo province with a population of 50 educators. The head of the educators said that each own a car. Two educators were randomly selected, one after the other, without repetition. Now let's explain this question. This 50 here, it's a sample number of educators who were being asked. There are 50. So our sample in this situation is 50. So 50 was sample. So let's say that this 50 is sample. This 50 here is sample. So 50 is our sample space. Now 30 educators indicated that there was a car. So those who have a car, they are 30. Remember now, those not having a car, there will be 20 because they should make up the entire space. So we can call these two having a car, not having a car, as a what? As a complement events, because they make up the entire space. There's nothing outside of having a car, not having a car. Now they said two educators were selected randomly, meaning that we have two branches because of choosing of two educators. They say represent the information in the diagram, clearly indicate the possible outcomes of the event. Now let's to start here. So in the first event, remember one of the events will take place. Either you're going to choose one with the car or one without a car. That's the first event. So now, how many are having cars? So 30 out of those 50 educators have a car, and 20 out of those 50 educators don't have a car. Now, that is the first branch. This is the first branch. Then now the second branch here, it is linked to the first branch in this way. Now, let's assume the first teacher or educator that was chosen had a car. You want to choose again. Remember that there was no repetition, meaning that this was without replacement. That means that when he was chosen, he was out of the equation. He cannot be chosen again. So now, because he can't be chosen again, the number of teachers in this situation now in the second event, they've decreased by the teacher that was chosen. So we check which one was chosen. That's how they decrease. So here, one with the car was chosen. Out of 30, one was chosen. So now we are left with 29. We're left with 29. But the number of the sample now is no longer 50 because one was chosen. So the number decreased to 49. But the one without a car was not chosen. So there are still 20, but out of 49 teachers. So let's assume that the first event didn't happen. What happened? The ones were chosen were the one without a car. So meaning the number of teachers with a car, they've remained as what? As 30 because they are not chosen here. But out of how many? Out of 49 because one educator was chosen. But the educator chosen was not a car. That makes them left with 19 out of 50. Then now we can write now that the outcomes now is having a car, having a car, having a car, and not having a car, not having a car, and having a car, not having a car, and not having a car. That would be the outcomes. They say now find the probability that only one, not at least. If at least we can even choose two, but here the specific of only one educator selected owns a car. So where is one educator selected car? These educators here, two owns a car. Here one owns a car. So this is where one owns a car. Another one owns a car. Here none owns a car. So we're dealing with here. They didn't tell us about the order of how they were chosen, so we don't care about the order of how they were chosen. So if they tell us the order of how they were chosen, we're going to focus on the order of how they were chosen. But in this case, you can choose one with the car and follow with the one without a car, or you can choose without one without a car and then follow with the one with the car. So because we see or it means addition, then let's take the probability of choosing one with the car is 30 out of 50 multiplied by, because it's end, by one without having a car, which is 20 over 49. Plus choosing one without a car, which is 20 over 50 multiplied by choosing one without a car, which is 30 over 49. So what is the probability of choosing here? Probability of choosing here, it is 30 over 50 multiplied by 20 over 49 plus 20 over 50 divided by 30 over 49. So this makes this to be 24 over 49. So the chance of choosing one with the car is 24 over 49. 10.2.3. Let that the two educators selected owns a car. So where do we have a car? This is where we have a car and a car. We're dealing with a car and a car. So this is where we have our 10 point. This is our 10.2.2. Then now let's look at 10.2.3. We need one with the car and the car. So this is probability for choosing a car and a car, which is 30 over 50 multiplied by 29 over 29. So this is where both have the cars. It's 30 over 50 multiplied by 29 over 49. So which this makes it 87 over 240. I think it's 5. Oh yes, 245. Okay. Now let's look at 10.3. 10.3 says you require a password for an online account. The password must have 3 numerical values followed by 2. Okay, then how many passwords are possible in the if repetition is allowed? Let's look at numericals. Numericals values, how many are they? Is 0 to 9. And how many of them we have? But out of these 10, we need 3. And out of these 5, we need 2. So now, let's look at 10.3.1. Is allowed. If repetition is allowed, what does that mean? That means that I'm going to choose out of 10 for all the possible choices. So for the first digit, I can choose out of 10. For the second digit, I can choose out of 10. For the third digit, I can still choose out of 10. Then now, I'm going to choose the vowels. The vowels I can choose out of 5. And for the first, for the second one, because they are just have to be with the repetition. So repetition means that I can choose it again. So it's 10 times 10 times 10 times 5 times 5. It's 10 times 10 times 10 times 10 times 5, which this makes it 225,000 ways or possible passwords. Then now let's look at 10.3.2. They say determine number of possible passwords if the conditions, with the following conditions. If repetitions are not allowed, repetition not allowed, it means that I choose a number once. So when I make a first choice, I can make a first choice out of everything, but as I make a choice, the chances are decreasing because the number that I chosen is not allowed to be chosen again. That's what I mean by repetitions are not allowed. Password does not start with 0. So remember that I had 10 digits, but now I don't start with 0, so I'm left with 9 numerical values. So I'm going to make a choice out of 9 for the first one. They will check the second one. For the first one, out of 9, because now I can choose what? I can choose 0. And end with the vowel A. So meaning that out of the 2, already I know the choice of the last one, which is A. So I have to choose only one vowel, which is going to be out of 4 because I removed 1. So because I had 4, I'm already 1 out. So for the second letter, I have to choose out of 4. So let's check. To choose the first one, the first numerical value, I'm going to choose it out of 9 because now the 0 is out. Now for the second one, because repetition is not allowed, I can't choose this one again. So I can choose this one again. As we chose 1, you can choose 1 again. We choose 2, you can choose 2 again. Every number that you choose, but you can choose 0. So meaning that for the first one, I had 9 to choose from. I've chosen it. Now for that one, for the first one, I had 9. But now this was for the first. And this 9 does not include, not including 0. Not was after including 0. But for the second one, I can include 0, but I can't include the number I've chosen here. This brings them back to 9 again. So I'm going to choose out of 9. Because now this 9 includes 0. but exclude the number that I've chosen first here. Then for the third one, I can choose out of 8 because the 2 I've chosen already here. Then now, to choose a vowel, I'm going to choose out of 4 because I know the last one have to be A. So because there's only one A and the repetition not allowed, so I can't choose it. I have to choose. It was chosen for me. So it's 9 by 9 by 8 by 4 by 1. So what is the chance? The password that I get 2, 5, 9, 2. These are the number of passwords that I can make with that condition.